Ladies and gentlemen, I would like to present the paper The Use of TLS Technology in the Inventory of Damage to Building Objects Resulting from the Impact of Underground Mining Exploitation. The research has been conducted at the Silesian University of Technology by Ryszard MIELIMOKA, Paweł, SIKORA and Przemysław MAZUR in Poland. The main goal of the paper is to present the possibilities of using TLS technology to assess the degree of damage caused in a single family building subjected to the influence of underground mining exploitation based on the example of actual measurements of a building located in the mining area of coal mine Chwałowice. The carried out imaging allowed to identify numerous gaps and cracks in the facade of this building and to measure their geometrical parameters. Mining damage is understood as all movements of rock mass as well as a collapse or uplift of the surface ground of mining area, affected by underground mining activities and contributing to incurred losses of property owners. The damage visible on the facades of buildings is mainly in the form of gaps and cracks, which are the result of stresses affecting surface objects in the deformation process of the surface ground subjected to the influence of mining exploitation. These stresses are mainly the result of the impact of extreme in time principal horizontal deformations and extreme in time main curvatures created in a developing subsidence throw and acting on the building structure. On this slide, exemplary cracks in the facade of a building located in the subsidence throw are presented. For the purpose of assessing the suitability of the terrestrial laser scanning technology for inventorying the damage to objects, a three-dimensional numerical model was made of a single-family building located in Rybnik. The building is located in the area that is strongly influenced by underground mining. To make the model of the entire building, the scanner Faro Focus S350 was used. The gaps of larger size found on the facade of the building were inventoried using the Faro Freestyle 2 handheld scanner that allows to capture more details of the surface. The point cloud obtained from 8 scanner stands of the stationary scanner was processed into a three-dimensional model of the tested object using the software Faro Scene. In effect, a high-quality imaging was obtained. The image was also devoid of vegetation fragments that would reduce clarity. The created model very clearly shows cracks and scratches in the building's facade. Their irregular course was reconstructed, ensuring the preservation of the smallest details. The cyclically created studies, combined with the function of linear and angular measurements offered by the software Faro Scene, allow to carry out precise observation of the propagation of the shape and size of almost any damage to the object. For the most extensive gaps, which pose the greatest threat to the structure of the object, models with increased accuracy were also made, using the data obtained with a handheld scanner, which were then processed in the Faro Scene capture program. The processing of point clouds was largely the same as in the case of a stationary scanner. The created models made it possible to measure the geometrical quantities characterizing the cracks, such as vertical dimensions, horizontal dimensions, total length, and width. As it has been demonstrated in the research, the TLC technology may be useful in the inventorying process involving the impact of mining damage to building structures. The obtained accuracy of the point cloud allows for very precise documentation of the occurrence, location, and shape of any cracks and gaps on the walls of buildings. A still higher precision of imaging is offered by the handheld scanner. In conclusion, we can state that due to significant improvement in accuracy, which goes hand in hand with saving time and labor, the terrestrial laser scanning technology can be widely used for the documentation of the impact of mining exploitation on surface ground objects. Thank you for your attention.